Hello grade 10s, welcome to another trigonometry lesson. Today we're going to apply the theory and knowledge that you've gained already, and we're just going to test to see if you can interpret questions based on your law SOHCAHTOA and based on your knowledge about the cast diagram. So I'm diving straight into an example. This may look very familiar to Friday's homework, and so if you have not done that work, it is expected of you to catch up and stay up to date because we are moving at a rate of knots. Rightio. If 2 cos theta plus the square root of 2 equals 0, and theta is an element of 180 degrees to 360 degrees, find the value of sine theta without a calculator and with the aid of a diagram. Now I know this seems extremely complicated at first and perhaps you don't even know where to start. So let's look at the information we've been given. You will always be given 2 pieces of information, and it is required of you to use those 2 pieces of information to do exactly what we did on Friday, and that is to determine the angle, the quadrant in which the angle theta will lie. So let's have a look at 2 cos theta plus root 2. We can do nothing with that until cos theta is the subject of the formula. You will be using the cast diagram, so sketch it on every single page. Whenever you do trigonometry, the cast diagram needs to be nearby because we refer to it always. Now let's make 2 cos theta plus root 2 equals 0. Let's work with that and make cos theta the subject of the formula. If we take the positive root 2 to the other side of the equal sign, it will become negative root 2. And then we can divide by 2 on both sides, and we get cos theta is equal to a negative root 2 over 2. That is our first piece of information that we need to apply to the cast diagram. Now I've emphasized that cos theta is a negative number. So we need to go and put a dot or a tick or a cross or a star, whichever symbol you like, into the negative cos quadrants. Quadrant 1 is A, for all trig functions are positive there. Quadrant 2 and 3 belong to sine and tan. So that is where cos will be negative, hence there are blue circles in those quadrants. Now let's whip out our magnifying glass and think, what other piece of information could we possibly use to help us find the quadrant in which theta lies? Aha! It tells us that theta is an element of 180 degrees to 360 degrees. So the angle, if an angle were to be bigger than 180 but smaller than 360, it would lie in quadrant 3 or 4. Now, hence I have those yellow dots in quadrant 3 and 4. Now we can conclude that we better make a sketch of a triangle where the green and yellow dots coincide, and that is quadrant 3. So make a sketch of quadrant 3, pop a right angle triangle into the quadrant. Remember, the right angle must sit on the x-axis, and then we must find all 3 sides of the triangle. Now if you have a look, cos theta is always equal to adjacent over hypotenuse for SOHCAHTOA, or you can say shade your rear cos x rays. So the x value is at the top of the fraction while the y value is at the bottom of the fraction. So let's link that up. Root 2 is at the top of the fraction, so our x value must be the square root of 2. I've placed a negative next to the square root because we are working in quadrant 3, which means we are working on the negative half of the x-axis. So this distance over here is root 2 units, but because we're on the negative side of the x-axis, it is actually negative 2, and that is where that negative belongs. The negative over here belongs to the root 2. Now the bottom of the fraction is a 2, and you can see that in the cosine function formula, x over r, the bottom of the fraction represents a radius of a circle, aka the hypotenuse of the triangle. So we pop in a 2 along the hypotenuse. Now, how on earth are we going to be able to solve for this third side? Well, we've got a right angle triangle, and good old Pythagoras will allow us to take the hypotenuse squared and then subtract the x value squared, so 2 squared minus negative root 2 squared will give us y squared equals 2, and so our y value must be the square root of 2. But look over here. We have to make it a negative root 2 because we are working in quadrant 3, and in quadrant 3 we deal with the bottom half, the negative half of the y-axis. So a vertical distance must have a negative number popped right in front of it. Now this is all the diagram and all this working out needs to be done before we can even answer the question, being find the value of sine theta. But we're ready now because we have all three sides of the triangle. So we can find sine theta because we know sine theta is shade your rear, y over r. So the y value in this triangle is negative root 2. And the r value is 2. Hence we have negative root 2 over 2. Easy peasy. Now let's see if you can follow the exact same thought process in order to complete this example. If you're feeling confident, pause the video and look at your two pieces of information to find the quadrants in which theta lies, make a sketch and solve for A, B, and C. I'm going to give you an opportunity to pause, otherwise just carry on playing. Right, let's have a look at our first piece of information. Cos theta is 1 over root 2. Now 1 over root 2 is a positive number. So let's go and place a dot in the quadrants in which cos is positive, and that's quadrant 1 and 4. Let's see our second piece of information. Tan theta is negative. So let's go and place yellow dots in the quadrants in which tan is negative. That would be the S and the C quads, right? Now both pieces of information coincide in quadrant 4. So that is the quadrant in which we must sketch a right-angled triangle with the right angle sitting on the x-axis. Theta rotates in an anti-clockwise direction from the x-axis to the hypotenuse, and cos theta we link up to being x over r or adjacent over hypotenuse. So if we link up our numerators, you'll see that 1 is your x value, is your adjacent value, and the square root of 2 is your r value, which is also your hypotenuse. So let's substitute those values in, and you guessed it, use Pythagoras to solve for y again. So now we're doing a subtraction sum, and we take the hypotenuse squared minus the adjacent side squared. We end up that y squared equals 2 minus 1. So that means y must be the square root of 1, which is 1. Why have I put a negative in front of this 1? Because we are dealing in quadrant 4, which means we're working with the negative half of the y-axis. So you have to show me that that number is a negative, and you have to use the reason Pythag to tell me how you got this value. Right, now we are ready with three sides of this triangle. We can tackle any problem that they throw at us. So let's find A, the value of sine theta. We know sine theta is y over r. The y value is negative 1. The r value is root 2. That's that. Leave it and you are done. B, tan theta, shade your rear because x-ray is tan your exterior. We know the y value is negative 1. Our x value is positive 1. So that simplifies to being negative 1. Last but not least, we know that sine squared theta is shade your rear squared times tan theta, because x-ray is tan your exterior y over x. Now substitute in the relevant values and simplify to get negative a half. Now this kind of question is slightly different to the ones before because it clearly states in terms of. If you see these three golden words, in, terms, and of, in a trigonometric question, just know you have to sketch an acute angled triangle. You will always be given the words in terms of. That's the alarm bell. That's the clue that says, hey, 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 sketch a right angle triangle. And you will also be given a variable. Now, the special thing about this variable is that you can convert it to a fraction. So if you see the variable and you see the words in terms of that variable, you must realize, okay, I need to convert my variable into a fraction. How do you convert anything into a fraction, any whole number? You pop it over 1. Now we have a numerator and a denominator that can link up with SOHCAHTOA or shade your rear, because x-rays tan your exterior. So in a right angle triangle, we have 2 of the sides already. Note that that would be theta, this would be 90 degrees, and if you had to find the third angle of the triangle, you would take 180 minus theta minus 90 degrees, and you'd end up with 90 minus theta as the third angle of the triangle. Now we already have 2 sides of this triangle. We have a y value and an x value. We have the opposite to theta and the adjacent to theta values as p and 1 because we converted p into a fraction. So once again, using Pythagoras, we can find the third side of that triangle. What would the length of the hypotenuse be? Well, the hypotenuse is often referred to as r, so r squared would be this vertical distance squared plus the horizontal squared. So that's p squared plus r squared. Now how do we make r the subject of the formula? We square root both sides and end up with r is the square root of p squared plus 1 squared, and 1 squared is just 1. Please do not make the fatal error of trying to split the square root and saying r is equal to p plus 1 because you've square rooted p squared and you've square rooted 1. We cannot split a square root sign when you are adding two values together. Right, so this is the value of r in terms of p. So we can write it down on this triangle. Now we have all 3 angles and all 3 sides of this triangle, so we can tackle the question. What is the value of cos theta? Well, we know that cos theta is x over r, or adjacent over hypotenuse, and that would be x is 1, our hypotenuse is p squared plus 1, and so our cos of theta is 1 over the square root of p squared plus 1. What about sine theta? Sine theta is y over r, the vertical distance is p, and our r is the root of p squared plus 1. It's as easy as that. Now what about this little tricky guy? What is tan of 90 degrees minus theta? Well, now we need to use SOHCAHTOA, but from the angle 90 minus theta. We are not going to worry about theta anymore. We're going to go SOHCAHTOA from this angle as a reference point. So TOA, tan, is opposite over adjacent. Opposite to 90 minus theta is 1, and adjacent to 90 minus theta is p. So tan of 90 minus theta is not the same as tan of theta, because tan of theta is p, so tan of 90 minus theta is 1 over p. Now I'd like you to use all this information in doing your homework, which is presented as a worksheet on the next slide, but you will also find this worksheet attached to the to-do list for the day. Please check the memo and enjoy.